Hello! I hope you all enjoyed your catch-up week last week. If you're still behind, please just do your best to do what you can, and if you need help, please reach out. We can schedule Zoom meetings anytime, any day. Just to give you a quick overview of from now until the end of the year. So this week we're going to be doing word problems and practice problems. We might get to special triangles on Thursday, depending on how we're feeling. The following week will be a review day and then your test, your Unit 8 test. Once we're done with Unit 8, that will be the end of new material for the year. And from that point till the end of the year, it'll be makeup work and potentially extra credit to bring your grade up. So if you've been doing your job, your year might be over next week. And that's pretty exciting. For those of you that need to catch up, let's get you there so that this online learning doesn't have to drag on longer than we need it to. So today we're going to start with a little recap of what we did last week. So this can act as kind of a general overview. We kind of do one of each example type. So this first example, a lot of the feedback that I was getting from last week is that the hardest part is deciding between sine, cosine, and tangent. So just as a review, sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So what you're doing is when you're labeling a problem like number 1, you're saying, I've got opposite and I've got hypotenuse. So which of these three has both hypotenuse and opposite? It's this one. So we're going to do sine of 42 equals opposite over hypotenuse. Now to move the 25 to the other side, the inverse of division is multiplication. I'm going to multiply both sides by 25. And if we round our answer, we get x equal to 16.7. Let's do another example here. Example number 2. This would be opposite, and this one would be adjacent. So look at our little signatures here. Opposite hypotenuse, so that one wouldn't work. Adjacent hypotenuse, so that one wouldn't work. So it must be tangent. So this would be tangent of 75 equals the opposite over the adjacent. Now this is the one that I think is the most tricky because the x is in the denominator. So after you multiply both sides by x, and you get x tangent 75 equals 12, then you've got to divide by the tangent of 75 as well. And you end up with x equals approximately 3.2. Now remember, if you don't have a scientific calculator, you're going to desmos.com for your free online calculator. Next, we have, let's see, this one is the first one. We don't have an opposite side. So we have an adjacent and a hypotenuse. So if we go back up here, adjacent hypotenuse is cosine. Cosine of 36 equals 19 over x. Okay, that one, our x is in the denominator again. So if you're quick math and you're starting to pick up on the patterns, we know that x is going to equal 19 over cosine of 36. Okay, I can't do that. I have to actually move over the x first and then divide. Otherwise, I end up accidentally flip-flopping them and I do like cosine of 36 divided by 19. Don't make that mistake. If you need to write it out, please do. There's no prizes for shortcuts. Last example here with finding side lengths. This one is opposite, and this one would be adjacent. So this would be tangent of 53 equals x over 7. Multiply both sides by 7, and you end up with x equals 9.3. So that's a quick review of finding side lengths. The next example set is finding angles. So remember, you're going to use the same SOHCAHTOA to choose which one we're going to need to do. So this one is opposite, and this one would be adjacent. So opposite and adjacent would be tangent. So I'm going to write tangent of x equals, and then I'm going to do 9 over 20. Now, since the angle is like embedded within the tangent, we have to do something to cancel out the tangent action. So that's called using the inverse. And we write that as inverse tangent. It looks like it has a little -1 up there. And then we put in the fraction. And that's how we can find the missing angle. That inverse tangent of 9 over 20, you're going to type that into your calculator. If you're using Desmos, you have to go over to, I think it's the function setting. It's not on the main page. You have to click over in order to find it. But when you type that in, you end up with your missing angle of 24.2 degrees. Okay, we've got another one here. This one would be, let's see, this is hypotenuse and this is adjacent. So that's cosine. So cosine of x equals 17 over 32. So you're going to do the inverse cosine of 17 over 32, and you're going to put that in your calculator. You end up with 57.9 degrees. Two more examples just to make sure that we are all on the same page. Let's see. Opposite, adjacent. So that's another tangent. So you get tangent of x, 13 over 18, inverse tangent. Typing it into my calculator right now, get 35.8 degrees. Last example, we have opposite and hypotenuse. So if you are looking at this and you're going, what in the world, how in the heck is she getting the opposite and the hypotenuse stuff? That's where you can either go back to the beginning lessons or let me know and we can do a little one-on-one meeting and I can kind of explain the thought process there. So this last one, if you're typing it in correctly, you get 48.6 degrees. And these are all rounded. Obviously, doesn't really make sense to go on for a million decimal places when you're dealing with angles or side lengths, really. Like 1 or 2 decimal places is going to be a-okay. All right, so let's get into actually what we want to do today. So this page right here, this is just extra practice. So if you feel like you need it, you can do this. If not, you do not have to do this, but I am happy to do these with you. Right now, what I'm going to do is just write the correct answers down here so that if you want to do it, that you can check your work. So we've got 7.3, 33.3. This is a mix of both angles and side lengths. So maybe you're good with the side lengths, so don't do those. Maybe you suck at the angles, so maybe do those. Right? The purpose of this is not to give you extra work, it's to give you the additional practice if you need it. And that's 64.2. That's a little sloppy. 12.8 degrees, and the last one would be 51.3 degrees. Okay, so again, do that extra practice if you need to. If you want me to do it with you, let me know and I'm happy to do it. Oh, we got more practice. Okay, 24.4, forgot about this page. Okay, let's actually do one of these because these problems are really intimidating. There won't be any like this on your test, but it's nice to just see an example or two. So here, if I'm trying to find PS, that's this one over here. Okay, this is my ultimate goal. But when I'm looking at this, if I were to use this smaller triangle, I don't have any of those. I have an angle, but I don't have any of the side lengths. So I actually have to use this larger triangle first and find this side length to then be able to find the side length I'm actually looking for. So to find the question mark one, that would be opposite over adjacent. So we would do tangent of 28 equals question mark over 39. I would have to do that first to find that this missing side length right here is 20.7. Then I'm allowed to use this 76, and here's my right angle right there. This would be this one would be opposite over hypotenuse. This would be my hypotenuse. So we would do sine of 76 the second time, and we would do 20.7 divided by x. So kind of a two-step process there to find your missing information, and you end up with x equaling 21.3. So no new concepts there, just you've got to do some visualization. For this one, you're looking for CDB, which is CDB. So you're actually trying to find this one right there. So same concept, you're going to have to find this connecting piece first. Once you have that connecting piece, then you'll be able to solve for the missing angle. Here's some two word problems, and this is what we're going to be focusing in on today is the word problems. So when you're doing the word problem, the number one thing again is to draw yourself a picture. You must be drawing yourself a picture. So when this is saying Max built a skateboarding ramp that is 16 inches high, right away I'm saying, okay, there's 16. The angle formed by the ramp and the ground is 21. So you've got to think about this. Where does the ramp go? This is how high it goes. So does it go, it's going to go down, right? So this flat piece right here, this represents the ground. So if it's saying the angle formed by the ramp and the ground, we're talking about this angle here because this is the actual ramp and this is the ground. So what is the length of the ramp? So are you trying to find the length of the ground? No, you're trying to find the length of the ramp. So that's your x value there. So this would be opposite over hypotenuse because this is a 90-degree angle. And you're going to get sine of 21 over 16 over x. So x is going to be 16 divided by sine of 21. So your ramp is going to be 44.6 inches long. Okay, when you're doing trig word problems, there's always going to be a ground or a wall or some part of like something that's stationary, and then there's going to be something that's leaning. But either way, you can do this. So a fireman leaned a 36-foot ladder against a building. So here's my building, and the ladder's leaning up against the building. So there's your ladder. And then obviously the other piece of the triangle is going to be from the building to the ladder. So let's find out what we know. If we place the ladder 7 feet from the base of the building, so that's this piece right here, that's 7 feet, what angle is formed between the ladder and the ground? Where's my other information? The ladder, we were told, is 36 feet. So I'm trying to find x here. So this would be adjacent and hypotenuse. So this would be cosine of x equals 7 over 36. So the inverse cosine of 7 over 36 tells us that that angle is 78.8 degrees. These two problems here are one of three major types of word problems that deal with trig. And it usually includes a stationary object like the ground or a tree or a building, and then something that you're leaning. So a ladder or a board, something like that. Your second type of common word problem has to do with angles of elevation. So what you need to know is elevation always means that something is going upwards. So when we draw the pictures for these problems here, the line of sight, you can see the picture over here, is always pointing up. It's like you're looking up at the sun, elevating it. Okay, so if you're hurt, right, you're putting your leg up. You're elevating it. So let's do an example. I'll do two examples with you, and then you're going to do the rest of those on your own to keep practicing. So the first example we'll do is we'll just start with number 1. So Casey sights the top of an 84-foot tall lighthouse at an angle of elevation of 58 degrees. If Casey is 6 feet tall, how far is he standing from the base of the lighthouse? So, we got to figure this out. Let's read it again. Casey sights the top of an 84-foot lighthouse. So let's start by actually drawing that lighthouse. There's my really, really poor attempt at a lighthouse. I know that that's not what it actually looks like, but it's 84 feet. Okay, then it says the angle of elevation, but right now I don't know what it's talking about. So I'm going to go to the parts that I know how to draw. If Casey is 6 foot tall, I know how to draw him. He's going to be 6 foot tall. Now I can actually, and then we're looking for how far is he standing from the base of the lighthouse. So think about his eyes. Okay, here's where his line of sight is starting, and he's looking at the top. So that angle of elevation is going from his eyes to the top. Okay, and that is 58 degrees. And we're trying to find out how far away he is. Now, the tricky part about these problems is in this particular example, Casey is not on the ground. So are we actually looking at all 84 feet? No, we're only looking from here to here. So we have to take that 84 and subtract Casey's height in order to find the part of the lighthouse that we need. Okay, this picture is getting kind of sloppy, I apologize, but that part is the only part that we actually need, and it's only 76. We don't have to use the full 84 feet because Casey is 6 foot tall. Now that we've labeled all of our pieces kind of sloppily, again, hopefully your picture looks better, now we can see that we have opposite and adjacent. So this would be the tangent of 58 degrees equals, opposite is 76, adjacent is x. So then this would be x equals 76 divided by tangent of 58. So Casey is standing 48.7 feet from the lighthouse. That one is very tricky because of Casey's height, but that's why I wanted to do that one with you as practice. The next one I want to do with you is, well, no, actually, I don't want to do any more with you. I want you to try, pause the video and try to draw your own picture. Now let's do the picture together. The angle of elevation from a kicker's foot on the football field to the top of a goalpost. So here's my kicker. The football is on the ground. Okay, that's important. And he's kicking it to the top of the goalpost. So they're saying that this angle here is only 17 degrees. If he is standing 131 feet from the base of the goalpost, so there's my other piece of information, how tall is the goalpost? So opposite, adjacent. So tangent of 17 equals x over 131. So how tall is the goalpost? X equals 40.1 feet. You'll notice a lot that you will use tangent a lot in word problems. That is because typically in nature, you're not given the hypotenuse. You might be asked to solve for the hypotenuse, but very rarely are you going to be given it. Okay, for 3 and 4, I'm going to draw you my picture, and then I really want you to do it on your own so that you can feel, do you actually know what's going on here? Okay, so Leah's mom is standing at the bottom of the slide. Here's my slide. Here's Leah's mom. That's my mom. That's not how I spell Leah though, that's okay. If the angle of elevation from the bottom of the slide to the top is 46 degrees. So this is 46 degrees. The slide has a vertical height of 9 feet. So there's my right angle. Find the length of the side. So here's an example, you're finding the hypotenuse. Now this is assuming that you have a straight slide with no curves or anything. So my picture is a little bit misleading, but here's an example where you wouldn't use tangent. Instead, we're actually going to use sine. So then you're going to find the length of the slide, which is 12.5 feet. Okay, and these are all based off of angles of elevation, meaning they're going upwards. So a dog is standing 5 feet from the base of a tree. So here's my stationary tree. And the dog, I don't know how to draw a dog. There's a dog. There's my dog. Is 5 foot away from the tree, looking up at a cat. Oh no, that's dangerous. There's a kitty cat. Okay, so the dog is looking up at the cat. That has climbed a 16-foot tree, so this tree is 16 feet. So what's the angle of elevation? Now you might be wondering, why aren't we accounting for the height of the dog? That's because dogs typically aren't huge. Like a person, like you're not going to get a 6-foot tall dog. Maybe like a 1-foot tall dog or a 2-foot tall dog, but not enough to really affect the problem. So when you're doing this type, this would be opposite and adjacent. But since you're solving for an angle, this would be the inverse tangent of 16 over 5. And you had to find out that the angle of elevation is 72.6 degrees. It is all about the picture. If I was not drawing pictures, I would not be able to do any of these problems. I really need you to understand that. Okay, the third type of word problem. So as a recap, the first type of word problem is what I like to call leaning word problem. So something's leaning on something else. Okay, that's word problem number 1. Word problem number 2 is angle of elevation going up. The last type of word problem is the angle of depression, which means it's going downwards. Okay, so you're looking down at an object. So it's going to change our picture slightly. It's not going to be the standard triangle that we're used to. This is the type of word problem that I struggle with the most. So let's work some of these out together. So the angle of depression is congruent. So this is a big part. So remember when we did parallel lines cut by a transversal, we learned that when you cut an angle or cut two parallel lines, that this angle is the exact same as this angle. That's going to be super key in our solving. So a lifeguard is sitting on a platform. So here's my picture right here. Okay, here's my platform. There's my lifeguard on top. Looking down at a swimmer. So here he is looking down. So there's my actual angle of depression right there. Okay, that's how far his head is going down. If the lifeguard's line of sight is 8 feet above the ground, okay, that means that he's 8 foot above the ground. The angle of depression to the swimmer is 18 degrees. So if this is the swimmer, here's the water. Okay, that means if this 18 is up here, that it's also down here. How far away is the swimmer from the lifeguard? So we're looking for this length right here. Hardest part about this is that angle. And if you find a really good way to remember that, please let me know, because these have always been the problems that are harder for me. So this would be tangent of 18 equals 8 over x. So x equals 8 over tangent of 18, which would be the swimmer is approximately 24.6 feet away from the lifeguard. Okay, let's do 4 more and then we're done. Okay, a pilot in a helicopter spots a landing pad below. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? So, let's draw a picture. Here's my helicopter. Looks like a goldfish, but there's my helicopter. And here's my landing pad. We know that the horizontal distance is 1,200 feet. And I'm trying to find the altitude, which means the height. So the angle of depression, and here's the mistake that every kid makes, is they want to say that the angle of depression is right in here. But remember, it's from the line of sight. So this angle is 73, which means when we're dealing with our triangle, this angle is 73 degrees. So this would be opposite over adjacent. Again, remember, you're going to use tangent a lot with word problems. So tangent of 73 equals x over 1,200. And you find out that the helicopter is approximately 3,925 feet in the air. So it is getting real close to landing. Okay, here we go. Building A is 480 feet tall. But then building B is 654 feet tall. If the angle of depression from the top of building B to the top of building A is 42 degrees, how far apart is the building? So this is what we're looking for. Okay, now the angle of depression, though, remember, is right up here. We create like a Z every time. So if this one's 42, then this one is also 42. Okay, because they're opposites. Okay, so right now it looks like we only have 2 pieces. So what other piece could we potentially find? Do we have the ability to find this piece right here? Yes, we do. We subtract the heights of the building to find the gap. So 654 minus 480 means that the gap between the building is 174. So there's my third number that I need. Opposite over adjacent. Tangent of 42 equals 174 divided by x. So the buildings are 193.2 feet apart. Okay, last one. Zach is standing at the top of a lookout tower and spots a water fountain below. If the lookout tower is 75 feet tall and the angle of depression is 28, what's the horizontal distance between Zach and the water fountain? So here's my lookout tower, and here's Zach, and then here's the water fountain. Yay, water fountain. Okay, so lookout tower is 70 feet, and we are looking for the horizontal distance. Now, angle of depression, oops. I always like to do the hypotenuse in a dotted line because then it's really easy for me to see the triangle. And then I always do the line of depression in a dotted line because I know that it's not the actual angle I want to use. It's the alternate interior angle that I want to use. So opposite over adjacent. So tangent of 28 equals 75 over x. So how far away is he from the fountain? Is 141.1 feet. Almost always with angle of depression, you'll use tangent. I'm trying to think of an example right now where I would have given you. The only one that I can think of is like maybe if someone's holding a string and then lowering it to someone else, or yeah, like maybe they're playing a really classic game of telephone, like where you put the cups on the edge of wires. So I would like tell you how far the wires are, but those would be rare. So for angles of depression, you're pretty much always going to use tangent. Okay, you are going to have a Math Excel assignment with this, and then we'll do some more another activity type problem for Wednesday later this week. Let me know if you have any questions. I'm happy to walk through some of these problems to help you out.